Today I'm how I did a video of me solving random number problem. So let's begin. So this is a continuation of the previous jump game problem, right? So the same thing here. We are given a zero index array of integer nums of length n. You are initially at nums of zero, so we will always start the first element or the first index, right? And we want to get to the last index. So the number C gonna represent the maximum number of jump we have, right? If it is two, which means we can jump one step, but we can also jump two step, right? And okay, so where each element of I represent maximum length of the forward jump from index one, from index I. In other words, if you are at nums I, you can jump to nums I plus j, where j is between zero and num I, for inbound, and I plus j is less than n. Okay. So we want to return a minimum number of jump, minimum, to get to nums of index one. Okay. So how can we figure out the number of jump? We can jump like this, right? We can also jump to three and jump three step to four, right? So how do we figure out the minimum number of jumps? So my first intuition is to use like dynamic programming. So and we can even, so normally if we use dynamic programming, right, we would have a DP, right? But in this case, we can just like reuse the input nums array to store our uh, input rate. Sorry, output rate. So let's look at the example here. So we have 2, 3, 2, 3, 1, 1, and 4. Right, and this is our index. Right. So first of all, it takes a zero step to get to 4. Right. We can start um from the last element and go backward. Right. So it takes zero step to get to 4. Right. So this is just it is just for illustration here. So we can take zero step. So if it is we are at 4 already, right? If we are already at 4, which is the last index, it takes zero step to get to 4, right? So if we are at 3, if we are at 3, then the maximum jump is only 1, right? So 1 is all we have, right? So 1 plus, right? So if we jump one step, then where are we at? We're gonna ask 3 plus 1, right? Which is 4, right? Because we are at 3, right? We jump one step because that is the maximum jump we are jumping, right? So we're gonna be at 4, right? So what is the minimum number of jump to get to 4, right? We already figured it out here, right? Which is 0. So this is gonna just be 0, right? So equal to 1, right? So it take 0 step to get to 4. If you are already at 4, if you are at 3, then it take only 1 step to get to 4, right? The minimum is this one. Okay. So we just keep building, right? And yeah, we can, because like we're not gonna reuse these elements, right? The maximum jump we only use it when we building out the minimum number of jump to get to the target. So after we figured out the solution, right? The minimum number of jump at 3, we can just rewrite it, right? Here, so this become 1, right? 0 step to get to 4, right? The minimum step to get to 4 from 3 is 1. Okay, so we can keep going. So if we are at 2, right, we also have the maximum jump is also is only 1, right? So we only have one option here. We can only jump one step, no other choice. So if we jump one step, we're gonna be at 3, right? Right. And if we are at 3, then so uh so we have to jump one step, right? And if we jump one step from 2, 2 plus 1 is 3, right? So we are at 3. So what is the minimum number of jump we need to take to get from 3 to 4, which we already figured it out previously, right? So which is only 1, right? So 1 plus 1 is 2. Okay. So if we are at 2, the minimum number of steps right? To get to 4 is 2 step, right? Sorry, two jump. Would make sense, right? We can jump here and here. We cannot like jump from 1 to 4. That's impossible. Okay. And then we can rewrite, right? So 1. Okay. So the next one is 1, right? Okay. So here we have to do it a little bit different, right? Because we have to take one jump, right? At least. So the jump here is the jump we have to take regardless of what happened, right? So the number 1 here gonna be the jump, the one jump, the one only one jump, right? But we can jump either 1 step, right? 2 step or 3 step, right? The jump here is the jump we have to take, right? Which only counts one jump. If we jump 1 step, it's also count as 1 jump. If we jump 2 step, it's also counts as like 2 jump, one jump, right? 3 step also 1 jump. Okay, so if we uh so 1 plus, right? Okay, so if we jump one step, where are we at? If we jump 1 step, we're gonna from 1, right? If we jump 1 step, we're gonna be at 2. If we jump 2 step, we're gonna be at 3, right? If we jump 3 step from 1, we're gonna be at 4, right? So what is the minimum number of jump to get to the target from 2? We already figured it out here, which is two step, right? So 1, right, plus 2 is 3. Okay. Um, how many jump that we need? What is the minimum number of jump we need to take from 3 to get to the target? Right. We already figured it out here, which is 1, right? So we can 1 here, 1 plus 1 is 2, right? And last one is 4. We just if we are at 4, then we take 0 steps to get to 4, right? So 1 plus 0 is 1. Okay. So we need to take the minimum, right? Because we only have one option up here, right? So the answer is going to be 1 and 2 and 0, right? So here we have 3 options, right? Because our maximum jump is 3. So we can jump 1, 2, or 3. So we just have to figure out the minimum, right? So as you can see, the minimum is this jump, right? Is if we take 3 jump, it will give us the minimum number of jump, which is 1. Okay, so if we are at 1, we can jump 1 step to get to 4, right? Okay, so after we figured out the answer, we have to update it here, right, in our DP. So now we are at 0 now, right? Um, it's 0 now. So we have 2 options, right? So again, the one here is the one jump you need to take, right? You can jump 1 step or you can jump 2 steps, doesn't matter, but it only counts one jump here, right? Okay, so you can jump 1 step or 2 steps. If you jump 1 step from 0, you're gonna get to 1. If you jump 2 steps from 0, you're gonna get to 2, right? All right. And if you jump, so how many what is the minimum number of jump you can get to the target from 1, right? Which we already figured out here, which is only 1, right? So 1 plus 1 is 2, right? How many jump, how many minimal jump that we need to take to get to the target from 2, which is 2, right? We already figured it out here. 2 plus 1 is 3. So the minimum gonna be 2, right? And we update this to be 2. Okay, so it makes sense, right? We can take 2 steps to get to 4. We can jump to 1 here, right? 1, right? Jump to 1, and then 1 we can jump to 3, to 4. So only 2 steps. So at the end, we can just return this, right? All right. So let's code this up. So we need to use. So we were using the num as our DP. Remember, we set the last element so equal to 0, right? It is the first approach is DP, right? So num.index, right, is equal to the minimum uh, jumps, right? The minimum jump, the minimum number of jump, right? To get to this index. To get to, sorry, the target, right? From to get to the last index, right? From this index position. Right? So the number index, right? Remember our DP, right? Which is the minimum. So the values here, right? Like the zero here, gonna be rewrite later, right? Zero here, gonna be the minimum number of jump that we need to take to get to the last index, right? From the current position. So if we are at here, at one, right? So the minimum number of jump we need to take to get to the last index from this current position, one, right? Just one jump. Okay. So let's continue. And we need a position first. So let's position is equal to our node supply minus 2. We start from the second to last element. So y position is equal to 0. Right. We will let mean step equal to infinity. Right. So we are guaranteed that we can reach nums of n minus 1. Right. We are guaranteed that we always have a solution. Right. So if we cannot get to the target, right, and then we can just set so for example, right, if we cannot get to index 4 from index 3, right, then we can just set nums at index 3 equal to infinity. So it takes infinity of jump to get to the last index, right? So that's why we can always pass the comparison. And we need the max jump distance. It will be equal to our num at I, right, at position. So before we rewrite, right, before we override it with the minimum number of jump to get to the last index from the current position, before we override it, then it's gonna still be the maximum jump, right, from the input. Okay, and we need to try for all distance, right? So it always counts as one jump, but we can jump like if it's a three, we can jump one step, two step, or like three step, right? So we need to try for all distance and take the minimum. Okay. So if the position, right, the position is the index here. If where we are at, which is the index, the position we are at, plus the current distance, right? If that is less than numbers line, then we want to update our minimum distance, right? Because we don't want to count um, the one that is outbound, right? So we have to update our minimum step. The min step equal to master min of min step plus one. The plus one here gonna be the one jump we have to take, right? Regardless of what happened. Sorry, between the min step and the one plus, right? We need to take the one jump here. Uh, then the num position plus the distance. Okay. So if we are jumping from this position, right? If we the distance can be one, two, or three, right? So if we jump one, then we are at two, right? Right. And okay, how many uh minimum number of jump we can it take to get to uh the last index, right? From number two, which we already built out earlier, remember? Okay. Then we just have to set the num position, go to the min step. So yeah, after we try all of the possible distance we can jump to, right? And keeping track of our of a minimum step, we just have to set the minimum number of steps, right, to get to the last index, right, in our DP, and then decrement the position and try the next number on the left side. And then at the end, we can just return them to zero. Right? Custom at zero will be the minimum number of steps, right? We can get to the target, right? If at any point we cannot get to the target, right, we just set it to our DP, and it's just gonna be infinity, right? So it won't wait fast in comparison. So the let's see. So the one here, right, is this one over here, right? Plus the nums, right, at the current position, right? So current position is 2, right? If we sorry, current position is 1, right? If we jump 2 steps, we're gonna be at 3, right? And we want to see the minimum number of jump. We have to take from that position because we are adding, so we know that we always like looking on the right side of the current position. And on the right side, we already built out our DP, right? Because we're going from right to left. Okay, so work. Okay, so yeah, I think that's what it is. Let me just like try to run this to see if it pass the test. Okay, cool, and it worked. So let's talk about the runtime. So the runtime gonna be O of n, right, multiplied by m, because we need to try like for every single distance, right? So m here gonna be the largest number, right? The largest, so the max jump, right? If the max jump is like 1,000, then we need to try like 1,000 times, right, to pick the minimum. Okay. All right. So this is the DP approach. So it is not very efficient. It is efficient, but it's not efficient enough. It's not yet the optimal solution, right? So we can try the optimal 3D approach. Okay. So what else we can do if we don't use the DP? So let's see. So if we look at the example right here, 2, 3, 1, 1, and 4. This is our index. Okay. So the strategy here is that we can delay our jumps as long as possible, right? So for example, if we can get from, so if okay, we're gonna start iterate from left to right. So at 0, right, the maximum jump, we always take the maximum jump, right? This is our, we need like a max and a new max. Sorry, what is it? Yeah, new max, like an O max, right? And then the jump. Okay, and this is our I, right? So let's say we are here, right? And then the maximum jump we can jump from 0 is 2. Basically, help us to get to 2, right? So this is the maximum number of jump. Sorry, this is the maximum distance we can reach, right? From 0, right? So we can set our new max to 2, right? I don't like this. Let's do this. Let's delete this. So let's put the new max. and the O max. Okay, so the new max is gonna be pointing at 2, right? So because the O max is pointing at 0, the O max is 0 initially, right? So it's also pointing at 0. So if this is our I, right? If I is equal to the O max, right? Then we have to update our O max equal to the new max. Okay. And then every time we update the O max, we need to increment our jump by 1, right? And we keep going, right? So from 1 here, right? From 1 here, the maximum distance we can jump is 3, right? 3 units. So we can get to 4, right? And that is larger than the current max. The current max is only 2, right? So we want to update our current max to 4 here, right? And I is not yet equal to the O max, so we keep going to I, right? Now the I is equal to the O max, so we update the O max equal to the new max. And every time we update the O max, we need to increment our jump, right? Right. And we just keep iterating to the end, right? 2 plus 1 is 3, 1 and 3 is 4, right? Which is never gonna beat our new max. The new max is 4, which already be the maximum distance, right? So yeah, after the loop, we can just like return a total number of jumps. Okay, so this is the algorithm that works, but why does it work? So let's slow down a bit here. So let's say we are let's say the O max is still at 2, right? Previously, and the new max is as 4. Right, I here. Um, let's see if we can try a good example. Okay, let's try 230. Let's try a different array so I can show it a little bit that better. So let me so let's try 2 3 0 um 1 2 2 3, for example. Something random 1 2 1 1 2 and 3. Oh 1 2 2 3. Okay, so this is our index. So 0 1 2 3 4 5 and 6, right? So again, we have our O max, right? Our new max, our index, right? So we can reach to 2, right? So new max here, because O max is equal to the new max, so it's equal to I initially. So we update our O max equal to the new max here, right? And now we have to increment our jump every time we update our O max, right? And we keep going. Okay, so 2, 1 plus 3 is 4, right? So we can reach 4. Right, so the maximum distance we can reach is for to update our max. I is not yet equal to the O max, so we keep incrementing I right here. Okay, so here 0 plus 2 is 2, right? So um because I is equal to so based on the algorithms, because I is equal to the O max, right? We need to update the O max here, right? And increment the jumps, right? But how do we know if we can get past 2, right? So let's say the OMAC is here, right? If we take one jump 2, then we cannot go anywhere, right? We're gonna get stuck here in the loop forever. Because if we are at 2, then we cannot jump anywhere, right? I mean the maximum jump is 0, which means we cannot jump, right? So we have to take the one step to 3, and then we can jump past it. Okay. Um, because because um because the O max is here, right? Which means the I will never get past the O max, right? we only update the O max every time I equal to the O max. So the I will never get past the O max. So as we iterating through the O max, right? We try every possible combination, right? Not every possible combination, but we try the maximum distance we can reach, right? So if we are at 0, right, the maximum distance we can reach is 2, which is here, right? If we at 1, right, the maximum distance we can reach is 3, right? Which is all the way here. So um so it doesn't matter. So okay, if we are starting at 0, right, the maximum distance we can jump is 2, right? So this is our reach, our maximum, the farthest we can reach, right? So it doesn't matter if we jump 2 steps or we jump 1 step. We don't care, right? We don't care. But as long as we can, as long as the new max reach a farther position, right? Reach a farther position, that we know for sure that uh, the difference between them is only 1 step, right? Because if the maximum we can reach is 2, right? We can jump 2 steps, but we can also jump 1 step, right? And from here we can jump to 4, right? So we are trying to delaying our jump as much as possible here, right? Because we are trying to take the free approach. We try to take the minimum number of jumps to get to the target, right? So the whole point is that this is the maximum point we can reach, right? The O max, the I never get past the O max, right? So from 0 to I, we already try every possible maximum reach we can reach from we can reach before the O max, right? If 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 the O max if the O max here, right, can get past the um if a new max here can get past the O max here, right? Then we know for sure that we can just have like we can only we can just take like one more jump to get past the wall here, right? To get past the O max here. So, um yeah, so the variable here we keeping track of the maximum um distance we can reach from 0 to O max, from 0 to O max, right? Right. So we can jump to here or to here, right? Doesn't matter. We can jump 2 steps. So that is like one one jump, right? But from here we can reach here, right? But from 1 we can reach here. But from 0 we can only reach to itself, right? So like this, uh, 3 to 4, right? 0 to 0. So these 3 possible jump, right? This is 3 possible max distance, right? Max position we can reach, right? From if we're starting from 0, right? And this 3 position is the maximum distance we can reach for the second jump, right? So in order to get from the new max O max to the new max, right? It's only take the maximum of 1 jump because the new max is jumping from the index over here, right? So it's only take the maximum of one jump to get to the next position, right? Because the new max here, right? Remember, we are jumping from here, right? Because the I never get past the O max. Okay, so that is the whole how it is in there. It's a little bit confusing and not like really intuitive. Uh, but yes, that is what we have. So we can have a new max equal to 0 and jumps equal to 0, right? And the O max equal to 0 also. We can return the number of jumps right later on. So for typing 0 or less than 1 line, then I plus plus, right? New max equal to max of max, right? After the new max So as we're iterating the I, remember, we always update our new max, right? The new max is the new max, right? And the position we are at plus the maximum distance we can jump, right? Jump is only as one jump, but we can jump. If the max jump is 30, we can jump one jump, two, or jump three, right? We always compare with the maximum number of jump, like where we can reach. Yeah. So yeah, if I equals to the O max, right? Then we need to we have we at this point, right? We must take a jump. Don't have any other choice, right? We must make a jump to jump to the next position and the next new max position, right? Because the maximum we can reach, right, from zero, remember, is only at two, right? At index two. So if we get to index two, then we need to jump, right? It we increment the jump when we are at index two, right? When I equal to the O max, but it doesn't mean we have to jump at two. So let me be like super clear here. So we are jumping, right? When O max is equal to I, which is at index two here. But it doesn't mean we have to jump at two, right? Because remember like the um the value earlier, right? At two is gonna be zero, which means you cannot jump anywhere, right? So the point is that if at if any point if at any position before index two, if we can get to a point like further than the O max, right? Which is the new max right here. The jump we have to take is only one. Okay. So let's try that. Okay, wrong answer. Let's see. So we have to start from the second to last one. We have to skip the last element because the last element is already the target, right? Okay. And that is so much faster. So the time complexity now is gonna be ON, right? No longer ON times M. And the space also reduced to constant space. And it is so much faster, as you can see. So thank you for watching.